Yep. And so outliers are pieces of data. Okay, quiet please. Okay, quiet please. Outliers are pieces of data that are way above or way below everything else, and there's an actual mathematical term for it. So there's a certain amount of spread that's expected to be within a bit of data. So like if I give a test, there's expected that I'm going to have some kids who score better than others and some kids who score less than others. So just because I give a test, and just because I have most of the kids score in the 70s, and just because one kid scores 100% and everybody else scored in the 70s, that kid who scored a 100% isn't necessarily an outlier. Just because they scored higher than everybody else doesn't mean that it's weird that they scored better. An outlier is a piece of data that is weirdly higher or weirdly lower than everything else. And there's a mathematical way to tell if something is an outlier. So let's say that we have all of these mall Santas, and we're going to take a look at their weights. Okay? So we have these different mall Santas, and let's say we got one mall Santa who weighs 250 pounds, another mall Santa weighs 230, we got another mall Santa who weighs 280, we got another mall Santa who weighs 290, we got a mall Santa who weighs 200. Well, they're Santas, man. They're supposed to be big guys. We got another mall Santa. We got another mall Santa who weighs 300. So let's see, we got 1, 2, 3, 4, 5, 6. We got a relatively trim mall Santa who weighs 190. We got a mall Santa who weighs 140. 1, 2, 3, 4, 5, 6, 7, 8. We got another mall Santa who weighs 310. And then another mall Santa who comes in at 235. So let's say we're a mall and we employ 10 Santas, and these are the weights of our mall Santas. Now, right away, just looking at this data, that 140 sticks out as being somebody who's super low. Okay. Also, we've got this guy who's, or it could be girl. I mean, maybe we're employing a girl mall Santa. Who knows? It's 2016. It's 2016. Right, exactly. So we got this one mall Santa, quiet, who's 310. Okay, quiet. So we've got these two Santas, one who's really low and one who's really high. So just because they're lower though and higher than everybody else doesn't automatically make them outliers. Outliers are pieces of data that are weirdly low or weirdly high. You automatically expect there to be some spread in any data that you have. And there's a mathematical way for us to find out if either of these two are what are called outliers, and they might not be. So how we're going to find out if they're outliers is first we're going to make our 5-number summary, just like what we were doing on everything yesterday. So for our 5-number summary, first thing we got to do is organize the data from smallest to largest. So which of these numbers is smallest? 140. So 140 is the smallest, and I'm going to mark that so that I know that I've already used it and I don't use it again. What's the next smallest?
190.
Okay, I'm going to mark that too so I know that I've already used it. What comes next after 190? 200. Okay. Next after 200? 230. Okay. Next after 230? 235. Next after that? 250, right? And if I make a mistake here, please feel free to tell me, but do it in a nice way. So 250, and then it looks like we make a jump up to 280, am I right? So we make a jump up to 280, and then it looks like we make a jump up to 290, and then 300 and 310. Okay, 300 and then 310. So I organize the data, that's my first step. Now I'm going to make my 5-number summary. So 1, 2, 3, 4, 5. And 2 of these 5 numbers are easier than the rest. So the smallest number is what? 140. And what's the largest number? 310. So those 2 numbers are easier than the rest. Now, to find the median number, I'm going to count towards the middle. So 140, 310, 190, 300, 200, 290, 230, 280, and then I have two numbers in the middle, 235 and 250. So I'm going to add those two together to get 485, right? And then I'm going to divide 485 by 2. So 485 divided by 2. 2 goes into 4 2 times. 2 goes into 8 4 times. So 2, 0, 8, 4, 0. And then I drop down the 5. 2 goes into 5 how many times? 2 times. So 4. And then I'm going to drop down a 1.0. And then drop down 0. 2 goes into 10 how many times? 5 times. So 242.5. So that's my median. And it was in between 235 and 250. So now I'm going to find the median of the lower and the median of the upper, right? So the median of the lower, so I'm going to discount all of the high numbers. And so 140, 235, 190, 230. And the median of the lower is what? 200. And I'm going to discount all the lower numbers and the median of the upper. So 310, 250, 300, 280, and the median of the upper is 90, or 290, sorry. Cool. All right, so far it's exactly what we did yesterday. Now I'm not going to use this to make a box and whisker plot. Instead, what I'm going to do from this in order to find out an outlier is I'm going to find something called the interquartile range. Interquartile range. And this in math is abbreviated as IQR. The interquartile range. We're not super creative, no. We didn't name it after anybody's girlfriend or anything like that. So, no, we didn't call it Felicia. So IQR. So the interquartile range is Q3, which is in this case 290. So 290 minus Q1, which in this case is 200. So the interquartile range in this case is how much? 90. Q3 minus Q1, which in this case is 90. And that's what the IQR, or the interquartile range, is. Now what we're going to use the interquartile range for is to test to see if either the 140, the super skinny Santa, or the 310, the really, really big Santa, we're going to test to see if either of those are weirdly skinny or weirdly fat, or if they're normal. Okay? Hey, your opinion doesn't matter. We're using math here. We're not using opinions. So, what we're going to do is we're going to do 1.5 times the IQR, and we're going to get a new number. So 1.5 times 90. So 1.5 times 90 is, in this case, 135. Now, I did that in my head. You can use a robot buddy. That's fine. Now, this 1.5, this came from a mathematical proof that was done about 150 years ago. For now, I'm not going to show it to you. You guys can just believe me when I say it's true. Unless you want me to show it to you. Okay. All right. So 135. Now, what we're going to do is we're going to take this 135. We're going to either add it to 242.5 or subtract it from 242.5. And if either of these two numbers are bigger or less than the median plus that, or the median minus that, then those numbers are weirdly big or weirdly small. So I'm going to do 242.5 plus 135, and I'm going to get a test number, and I'm going to do 242.5 minus 135. And I'm going to get another test number. And for that, I cannot use my brain, because I'm relatively good at math stuff, but I can't think of that this morning. So I'm going to use my robot buddy here. So I'm going to do 242.5 plus 135 and I get 377.50, and I do 242.5 minus 135, and I get 107.50. Okay, so these two test numbers will tell you above what number you have somebody who's weirdly fat, and below what number you have somebody who's weirdly skinny. It's probably not PC for me to use those terms. Instead of fat, I should say rotund? Plump. Politically correct. And then instead of saying skinny, maybe I should say adipose challenged? Adipose tissue challenged? And then instead of fat, maybe I should say adipose tissue gifted?
You just say skinny and fat. Those are words.
Okay. So if you didn't know, fat tissue, another name for fat tissue is adipose tissue. And so I could say, like, instead of saying fat, I could say adipose tissue. So this guy who's 140 and who's playing Santa, is he less than 107 pounds?
No.
No, he's not. Or she. This person, we don't know. Right, exactly. Let's not be sexist. It's 2016. This person who weighs 140 pounds is not less than 107 pounds. So even though they're pretty skinny for a Santa, they're not weirdly skinny according to math. Stop that. Tyler, sit up. So even though they're really skinny for a Santa Claus, they're not weirdly skinny according to math. They're not an outlier. And even though this person who weighs 310 pounds and is a Santa, even though they're pretty big, according to math, they're not above 377.5. They're not weirdly large for a Santa. So neither of these two people are outliers, according to math. So you might have your own opinion, and that's fine, you can have an opinion, but according to math, according to numbers, neither this person nor that person are weird for Santas. They might be weird for other reasons, but they're not weird because of their weight. What, Keith?
So I could be a Santa?
Sure.
I could be a Santa.
According to math,
I weigh 145.
according to math, and according to these statistics I just made up off the top of my head, yes, you could be a Santa. According to the statistics I made up. Sure, why not?
I couldn't be a Santa.
It's 2016. It's 2016. Why
I
not?
couldn't be a Santa.
All right.
It's almost 2017.
You're right. Let's wake up here, guys. All right, so I'm not going to give you guys a new assignment today. Instead,